staying in the sort of database space, but going into the Cosmos. And speaking about Cosmos DB and Azure Function. So, Will, if you are there, I'll hand over to you. Thanks everybody for staying here on Azure Platform Saturday, and enjoy the rest of the day.
Awesome. Thanks, Stefano. Can everyone hear me? Is my mic coming through okay?
Yep.
Fantastic. Sweet. Let me share my screen and let me set everything up. Sweet. Fantastic. Before I kick off, everyone can see the slides?
Yep.
Fantastic. Awesome. Well, hello. Good morning. Good afternoon. Good evening. Whatever time it is and where you are right now, wherever you are right now in the world, thanks for joining us. Thanks for joining me, and I hope that you're staying healthy and safe through these pretty unusual times. My name is Will Velida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand, and I'm really excited to be able to talk to you today about working with Cosmos DB in Azure Functions. Now, when I do presentations like this in real life, I usually take the opportunity to go around the room and ask whether or not they've used Azure Functions or Azure Cosmos DB, just to try and gauge what their experiences are with them, see if they've used it at all, etc., just so I can set expectations for the session. But since I can't see you all, I'm just going to set the expectations right from the beginning and say that this session doesn't really require you to be an expert in anything that I'm presenting to you today. You might be considering using Azure Functions. You might consider using Cosmos DB. You might have deep experience in both of those, both Cosmos DB and Azure Functions, or you might have no experience whatsoever. The point is, today is just about me showing you how you can use Azure Cosmos DB in Azure Functions and how fairly straightforward it is. I will be doing some code demos today. Hopefully they'll work. They were working before the presentation, but you never know. They will be in C#. So if you do have some knowledge in C#, that's great. That's fantastic. But if not, you should be able to follow along with the concepts and understand what's going on. Yeah, so let's kick into it. Just a little bit about me. Like I said, I work as a software engineer for ASB Bank in Auckland, New Zealand. If you haven't guessed by the accent by now, I'm originally from the UK, but I've been living in New Zealand for almost 10 years now. So I'm starting to acclimatize, I think. I'm also recently awarded Microsoft Data Platform MVP with a particular focus on Azure Cosmos DB, Azure Functions, C#, which is what I use in my day-to-day job. When I get the chance, play a little bit with Azure Databricks, Event Hubs, amongst other things as well. I've also been really lucky to speak at conferences around the world, both in person and virtually as well. And I like to blog on DevTO and Medium when I get the chance. And I'm also trying to start my own YouTube stuff, where I do more deep dive stuff into Cosmos DB. But anyway, let's move on to why we're actually here today. So today, I'll start off by giving you all an overview of what Azure Cosmos DB is, what we can use it for, and why I think it's a really fantastic database service in Azure. Then I'll dive into the details of how we can actually use Azure Functions to work with our data in Cosmos DB via the different bindings available to us. Then I'll talk a little bit about how we can use dependency injection in our Azure Functions to work with our Cosmos DB clients and why we might take that approach over using the bindings. Then I'll go through a demo and show you how all the different bindings work and how they will work together to do different things, and also show you how to use dependency injection in your functions and how we can work with that when we're working with Azure Cosmos DB and Azure Functions. And then after that, I'll show you some resources. I'll show you the demo. Hopefully everything goes well with that. And after that, I'll give you some resources. So if you're interested in exploring a little bit further, you can deep dive into those. And if we have some time at the end, hopefully we will, we'll have a bit of a Q&A for any questions that you might have. Sweet, so let's dive into it now. Okay, so Azure Cosmos DB is Microsoft's globally distributed multi-model database service. Using Cosmos DB, we can build databases using a variety of different data models. So, for example, if we were going to build applications using document models, we might opt for using the SQL API or the MongoDB API. If our applications are working with columnar data, we would provision a Cosmos DB account using the Cassandra API. We might be working with key value data. Those of you who've ever played around with Azure Table Storage, Cosmos DB provides a table API, which essentially is a global version of Azure Table Storage, which is fantastic. Or you might be even working with graph data. Cosmos DB provides an API called the Gremlin API that allows us to work with graph data. Essentially, Cosmos DB provides us with the ability to build highly responsive and available application that allows us to bring our users' data as close to them as possible. And there are a few benefits with Cosmos DB. So with that, there's turnkey global distribution. So essentially, Cosmos DB will replicate your users' data to wherever they are in the world. Cosmos DB is what we refer to as a foundational service in Azure. So you can add and remove any Azure regions to your Cosmos DB account at any time. And it's available all throughout every single Azure region throughout the world. So that gives us a lot of options to provision and replicate our data to. Cosmos DB will replicate our data to all regions associated with our account while our application continues to be highly available. Cosmos DB provides elastic scalability of both throughput and storage worldwide. So this is for both your reads and writes all across the globe, and you can scale up from thousands right up to millions of requests per second and only pay for the throughput that you need to actually deal with any spikes in your workload. Cosmos DB is also guaranteed at low latency at the 99th percentile worldwide. So this allows us to build highly responsive planet scale applications, and it guarantees less than 10 millisecond latencies for both index reads and writes at the 99th percentile, which is great for providing us with rapid queries and responsive applications. Unlike most traditional distributed databases, Cosmos DB actually provides us with multiple and precisely defined consistency options. So we no longer have to choose between two consistency extremes of either strong or eventual. Cosmos DB provides us with 5 well-defined levels of consistency to choose from, depending on the needs of our application. And there's also no schema or index management required, with some caveats. It does change from use case to use case, but Cosmos DB will automatically index all our data for us and is schema agnostic. So we don't have to worry about managing that if we don't want to, and we don't have to worry about managing downtime with relation to those to indexes or schemas. Cool. And we can use Cosmos DB for a variety of different use cases. So for example, we might have an IoT application that requires us to read telemetry recordings from devices all across the globe. We may have a mobile game that's used by gamers all across the world, and we need to bring their data as close to them as possible for rapid performance. We might have web or retail applications with customers all across the globe, and we need to provide them with ultra-fast retail shopping experiences by having their data as close to them as possible. Essentially, if we need a NoSQL database service that's ultra-fast and requires minimal management, then Azure Cosmos DB is a first-class service and a great choice for our data, for our applications. Okay, so let's get into how Azure Functions works well with Azure Cosmos DB. So for those of you who may not have a lot of experience with Azure Functions, Functions will provide us the ability to create scalable units of work or tiny, concise pieces of logic that can be run on demand without us worrying about provisioning or managing any infrastructure. And through using, thanks to this and using Azure Functions, we don't have to create these massive monolithic applications to actually be able to work with Cosmos DB. We can create small reusable functions for specific tasks that interact with our data in Cosmos DB, depending on what our needs are. And through some of the demos that I'm going to show you, you'll see that these functions are really, really small, and really there's about 80 lines of code in some of them, and not even that much lines of code. So we actually do some really sophisticated things through Azure Functions when interacting with Cosmos DB. We can get instant access to all of our data. We can work with schemaless data and build event-driven applications that allow us to scale globally. Thanks to Cosmos DB's global replication and distribution across the world, we can actually build small event-driven applications that are brilliant just for executing really, really quick tasks. And there are different types of ways that we can actually use Azure Functions to interact with our Cosmos DB databases. So, for example, we may want to execute a function that whenever a document is created or modified in a collection, we might want to run a function that listens to that collection in Cosmos DB and then invokes or gets triggered due to a creation or modification of a document in that collection. We may want to do a quick read in our collections based off a SQL query. So we might use an input binding to do this, just to read some data really quickly in our collection. Or we might want to write some data to our Cosmos DB collections. We might have an event hub. We might have an HTTP trigger that executes or triggers something. And then resulting from that, we just might want to write some data to a Cosmos DB collection. And we can use an output binding for that. Let's walk through some visual examples. So we'll start with the Cosmos DB trigger. This is a really simple way for using a feature, a really cool feature in Azure Cosmos DB called the change feed. So essentially what we've got here is we'll set up our function with a Cosmos DB trigger to listen to a container in our Cosmos DB account. And every time a document is created or updated, and I think resulting from build 20, they've actually released the ability to listen to deletes on that collection as well. Every time this happens, our Azure function will be invoked. And then we can produce an output based on the changes or the updates or the creation that have happened in that collection. So let's deep dive. Well, let's just dive a little bit further. Visualize this with an example just to make this more concrete in our mind. So let's say we have a function called purchase product. Say we have an e-commerce site, and every time a customer creates an order, we can use the change feed to produce an output depending on what we might want to do. So we've got a few options that we've got here. So what we've got, we could use the change feed to persist our document to another collection in Cosmos DB. We may want to do that for partitioning reasons. We may want to migrate our data from one Cosmos DB collection to another. But essentially what we can do is we can take the JSON document that we've persisted in our original product collection and then persist it into another collection via the change feed. It's a really straightforward and really simple way of doing that. And throughout one of my demos, I'll actually show you this in action. We also may want to take the JSON document that we've just created or modified and then store it into a colder storage that might be more suitable for analytical workloads. Now, Azure Synapse Analytics has come out, and there's a Synapse links for Cosmos DB, which enables a little bit more of a friendlier analytical approach through the analytical store to deal with this. But if that's not an option for you, you can still use the change feed from an Azure function to pick up your documents from your collection that you've enabled the change feed on, and then persist it into a colder storage that's more suitable for analytical workloads. And for those of you who may be more familiar with Azure Databricks, there's actually a special type of Spark connector for Cosmos DB, which essentially you enable the change feed onto it, and you can actually perform some machine learning workloads based off the changes or based off activity from the change feed. And you can actually perform some really cool and sophisticated machine learning jobs using Databricks in that way. So just to step back and
I'm just saying, I didn't quite get the change feed or what it is. It like an event or?
Yeah, I'm just about to dive into that. Sorry, if for those of you who just joined, can we perhaps do questions at the end? Just so I can, because I'm actually coming up to explaining what the change feed is. Okay, cool. So essentially what the change feed is, just to answer that question. So essentially any changes that occur within our container are produced as a sorted list of documents that the changes were made in the order that they were modified. And this allows us to process them incrementally. So essentially they just, whenever activity happens, so when a document is created or modified or deleted, the change feed registers that and produces it in a sorted list, and then that gets fed to whichever consumer is actually consuming the change feed. Now with the change feed, we're not limited to just a single type of consumer, so it's not like we have to set up multiple change feeds in order to do different things. So all of these consumers can actually consume the same change feed, and we can do some parallel processing. Now, Azure functions aren't the only way we can work with the change feed. There's also a processor library, which is a little bit out of scope for this talk. And you can actually do a whole separate talk on the change feed as well. But this is just using Azure functions is the easiest way to get started with the change feed. And with one of the demos, I'll actually show you how easy it is to actually get started with the change feed. It's minimal work at all. But for now, we'll just move on to the other bindings. So we can actually use an input binding to read data from our Cosmos DB collections. So for example, we might have a HTTP trigger as part of a serverless API to perform a particular query that retrieves data from our Cosmos DB collections. We can then use that output to return documents to the user as part of a web page, or just returns them a JSON response, which they can do to do another task. So essentially, if we need a subset of our data really, really quickly from our Cosmos DB collections, we can use an input binding to execute really simple queries to get our data back to us. For complex queries, it's not as suitable, and through the demos, I'll actually show you, I'll illustrate this point a little bit further. But now, finally, we can use an output binding to write data to a container in Cosmos DB. So in this example, we might have an HTTP trigger making a post request in the serverless API, or we might be reading events off Event Hub or off Kafka, which we want to consume and then persist those events to a Cosmos DB collection. And we can easily set up an Azure function with a Cosmos DB output binding to write data to our containers. So bindings are a really simple way for getting started with Azure functions and Cosmos DB, but there are some caveats to it. Currently, the bindings only support the SQL API. So like I said at the start, there are 5 APIs for us to choose from for our Cosmos DB accounts. But say, for example, we were using a different API rather than the SQL API for Cosmos DB, and we still wanted to build our applications using Azure functions, we would essentially have to either create a static client in order to do that, or we would have to use dependency injection. So you are limited to just using the SQL API within Azure functions. Each binding instantiates its own client. So if we have one function within a function application that executes every so often, this isn't a massive problem. But if we have multiple functions trying to make operations against our Cosmos DB database, this is a little bit of a performance hit, becomes unmanageable, and you've essentially got all these clients being instantiated and then closed off. It's just a bit of a mess, and there is a better way of doing it. And the bindings themselves, they still use version 2 of the .NET SDK for Cosmos DB. Now, for those of you who may have developed with Cosmos DB using the .NET SDK for quite some time, you'll know that version 3 has been out for a little bit of version 3 has been out for a while, and there's been some massive improvements in performance and ease of use for the SDK. So if you wanted to use the latest and greatest version of the SDK, then bindings are still not the way to go. Even in the version 3 of the Azure Functions runtime, if you are familiar with Azure Functions, they're still using version 2. So this is a bit of a limitation. However, since version 2 of the Azure Functions runtime, Azure Functions actually supports dependency injection, and this is very similar to, it's built on the .NET Core dependency injection features, and they use the same service lifetimes as ASP.NET dependency injection. So you can instantiate transit services, which is created upon each request of the service. We can create scoped services, so the scope service lifetime will match the function execution lifetime, and they're created once per execution. So you can create scoped lifetime services. Excuse me. And we can also instantiate singleton. So the singleton service lifetime will match the host lifetime, and then we can then reuse that singleton service across many different functions inside our function applications. Cool. So let's dive into our demo. Okay, so let me just open up Visual Studio. Cool. Let me reshare my screen for Visual Studio. Cool. Can everyone see my screen? I'm going to assume we just check Teams. Yep. Cool. Awesome. All right. So what I've got here is I've got 3 projects in Visual Studio. So I've got one core library, which is just essentially holding an instance of a class I'm going to work with. Now, for this demonstration, what I've got is we're going to be dealing with hotels. And so we're going to be a really simple setup here. So all I'm doing is I've got a hotel class with a hotel name, the star rating, and which city they're going to be in. And let's start off by exploring triggers. So I've got this project here that's just dealing with Cosmos DB triggers in Azure Functions. So to start off with, I'm going to insert a bunch of hotels into this collection for hotels inside my Cosmos DB database. So here I've got my binding. So I've set my database to hotels DB. I've got a collection name. I've defined a connection string setting for Cosmos connection, and this is related to just a settings file here that I've got in a local settings.json file. I can set the partition key, and I can also set preferred location. So like I said, Cosmos DB is a globally distributed service, and we can provision our Cosmos DB account to any place, into any Azure region worldwide. And we're just setting a preferred location. Say if we had a Cosmos DB account with multiple write regions enabled, I could just state to the Azure function binding saying this is the location that I want it to write to. Yeah, and essentially here I've got this a collection of hotels which I'm going to write to. So I'm using a library here called bogus.faker, which will just create a bunch of fake hotels for us to put into our Cosmos DB collection. Then I'm going to iterate over that enumerable list of fake hotels and just add it to this iasync collection of hotels. And then I'm just going to flush all of them and persist them to my Cosmos DB account, which I've set up. While that's happening, I'm going to create another function, or I have another function which has the change feed enabled on it. So here's my change feed Azure function. So here, instead of just this HTTP trigger, I'm just essentially going to use Postman to make a post request to insert all these hotels into. What I'm going to do here is I've got this Cosmos DB trigger. So I've got the database, I've got the collection that I want it to listen to. I've connected it to my Cosmos DB account. And then I've got something called a lease collection name. Now, essentially, for the purposes for the change feed, what this lease collection does, it actually acts as a checkpoint. So say if I'm running this function at a certain time in the morning, or I'm running, just say I'm running it at a certain time in the morning or at certain intervals, what this lease collection will do, it will persist the point to where it will persist the last point at where it's read the change feed from. So this setting down here, feed poll delay, this is how often I want the change feed to poll that this collection, this hotel's raw collection for any changes that have occurred since the last time it checked. And this lease collection will just checkpoint that for us. The great thing about Azure Functions, or the Cosmos DB trigger, that if we haven't created this lease collection name already, we can actually let the function create it for us. And then we can also configure it to start from the beginning or start from the last place that it checkpointed. This is just a true or false. And again, we can actually set a preferred locations, just in case if our Cosmos DB account was a multi-region write, had multi-region write capability. So what this will do, it will poll this container for any changes that have happened, and it will add them to this read-only list of typed documents. So what we're doing here with this list, we're going to say, okay, for every document within that list of documents, what I want you to do is create a new document within this new aggregate collection, hotel aggregate collection, and then just add the document to it. So it's essentially what we're doing here is just that example I mentioned earlier. So we're going to take our document from one collection and then persist it into another collection. And I'll show you the differences between the two collections in a little bit. And what we'll do is when we run this function, we're just going to say, okay, this document with this ID has been inserted into hotel aggregate collection if successful. And then just before I actually run this, we've also got another read function using the output binding here. So this function, here we've got our database name, our collection name, our connection string, but here we're running a SQL query that tells the function, okay, every time this function gets invoked, I want you to select all the hotels where the city name is equal to Redmond. And we're going to add them to this enumerable list. And if we can't find any, we're just going to log saying we couldn't find any hotels in Redmond. But if not, we're going to return those hotels as an object back to the user. Really straightforward. Now, I ran this earlier, but I will show you. Let me just reshare my Cosmos DB account. Okay, so I've got these three containers in my Cosmos DB account. So this will be my raw collection. Essentially, this is optimized for our writes. So we've partitioned it by the document ID. Now, for those of you who may know a little bit about Cosmos DB, and for those of you who don't, we can actually partition our data depending on our needs for our queries. And for write-heavy operations, we can partition it by ID, which is what we're doing here. And then we've got another container here that's got a different partition by city name. So this would be what this collection, sorry, is more optimized for read-heavy operations. So we can dive into that a little bit deeper later if people do have questions about partitioning in Cosmos DB. But essentially, just for now, this is our write-heavy, well, our write-optimized collection in Cosmos DB, and then this one, our hotel aggregate collection, is optimized for read workloads. Okay, let's kick into our demo. Well, let's kick into. Let's start this function off. Okay, so I'm going to start this off. And now I'm going to come into Postman. All right, so my function has started. What I'm going to do is just going to kick off this process by inserting hotels. So make that request. Let's open up the portal. Oh, sorry, my Azure function. So my function's running, and as I'm inserting documents, we're essentially the change feed is running automatically in the background. So we didn't have to kick that off ourselves. It's just listening to any activity or listening to the container where our documents are being created within our Cosmos DB account. So here we are. So documents with the document ID is now being inserted into hotel aggregate. So what we can do, let me open up the portal here. Sharing in Teams drives me insane. Cool. All right. So now, as we can see, we've got a few more items now in our raw accounts, and then hopefully when we refresh our aggregate, we'll see more documents being persisted into our aggregate table. So that way, the change feed has automatically picked up documents that have been persisted, it's listened to documents that have been created in our write optimized collection and has now migrated it or taken that document and then persisted it to our read optimized query collection. It's all in a few lines of code. It's really simple and straightforward. And as you can see, these functions aren't that big at all. So this one, the change feed is less than 50, 60, and then just let's say 45 lines, well, 44 lines of code. So in a few lines of code, we have created a sort of a semi-sophisticated data migration application. So we've taken it from a write optimized container. We're optimized one collection to optimize our writes, and use the change feed to then persist that into a collection that's probably more friendly for our read requirements. So what we can do is now test our read optimized function. So what this is going to be doing, we're going to create make sure I'm just sharing the right screen. Okay, so now what we're going to do is we're just going to essentially run this query where we get all the hotels from Redmond. So we just send it the request, and here we are. So here are all my hotels from Redmond returned to me from our Cosmos DB collection, all thanks to our output binding. So it's a really straightforward way just to do some cheap and dirty queries on our containers using Azure Functions with it's not a full-blown application. So something really simple and really straightforward to get going with that. Cool, so those are our bindings. So now we're going to move on to discussing dependency injection. So what I'll do is just switch my screen back to my project. Okay. So here we have got a startup class where essentially what we're going to be doing is we're going to be instantiating our singleton service for our Cosmos DB client. So here I'm using the function startup dependency injection class. I'm just inheriting that. And in this configure, what we're doing is we're configuring our singleton for our Cosmos DB client. So I'm passing through my connection string through here to the client, and I'm just returning it. And we can actually be a little bit more configurable with our Cosmos DB client. So in the function bindings, we were just specifying a connection string, and we were able to set a preferred region and specify the collection names and so forth. But with this, we have far more options now to actually customize the type of client that we're going to be using within our function apps. So here I'm using with application name, and I'm also enabling bulk execution. I might actually remove that and then just building it and then returning it. But using this option, we can change the type of connection mode that we're going to be using. We can actually, let's come down a little bit, add preferred regions. We can define our consistency levels. So if we have a particular type of consistency level that we want this application to use, we can specify that. We can specify throttling retry options, serialization options. So essentially, we can be a little bit more customizable and a little bit more flexible with the type of client that we're working with using this using the dependency injection approach. And let me just close my binding functions here. And essentially, with our functions, it's a little different setup. So here we're only using a trigger. We're not using any input or output bindings here. But what we're doing is we're just using constructor injection to inject our client. And I've created a container Here, as you can see, that we're now using the version 3 of the .NET SDK, and this allows us to treat components with a little bit more modularity. So here we've got our container. We're just getting our container from our client. So this is our hotel aggregate. And here we can be a little bit smarter with our SQL queries. So one of the big drawbacks of the bindings, when we're defining a SQL queries, I've seen this question pop up a couple of times on Stack Overflow. And they always ask, can you perform dynamic queries within bindings? And the answer is no. You can't pass through parameters to your bindings. You have to set your SQL query when you specify the binding. But here, what we've got with this route, we've essentially passing through this parameter of city name. So when we actually make a GET request, and to actually invoke this trigger, we can pass through any city name and the function will still return a result to us, provided the city name is a valid city name. So here what I've got is I'm creating this query definition where I'm going to select all the hotels from hotel aggregate where the city name is equal to whatever city name that we pass through to our function. And then I'm creating a feed iterator to execute that query and then returning the results of that back to the user. And just before I kick that off, I'll also go through insert. So again, we're using constructor injection. Constructor injection here to get to instantiate our container and our Cosmos DB client. Again, I'm using Faker here to generate some more fake hotels. So I'll just generate 100 just to show how that goes. And then from like every hotel within this list of fake hotels that we create, we're just going to be creating a new item in our hotel raw collection that we're going to be using up here. So it's still dependency injection in Cosmos DB is in Azure Functions is a really great way to instantiate a singleton service of our Cosmos DB client, and so they can share that same instance of our Cosmos DB client, which is great because then when we actually run this will hopefully be a little bit quicker than actually running it using the binding, since the binding instantiates its own client. Okay, let me start that. So restart our function. So here we are. I've got my two HTTP functions. So get hotels, where I can pass through the city name, and also insert hotels, which is essentially going to be the same as our binding, but for this instance, we're actually going to be using dependency injection instead. Let me just share Postman. Okay, cool. So let me insert some more hotels. And this will kick off our function again. So it's successfully executed. Let's hope nothing's going on. While that's happening, I'll show you the GET request that we can make. So this is essentially this time, instead of just defining this this route, so get hotels from Redmond, where we can't pass through parameters into our SQL query, here we're going to pass through a city name of Redmond. And this just makes it a little bit more configurable. So rather than creating all these different get functions to get data depending on which city our hotel's in, we can actually just pass this through as a parameter in our query. And there's different ways of doing this, but this is just a real easy example. And here we are. Here's our hotels being all from the city of Redmond being returned to us. So let's change this up. I've also got hotels in Paris, because Paris might be a place that we want to visit instead of Redmond. And there we go. So it just allows us to customize our queries and pass through different parameters into our queries through dependency injection. And that's a pretty straightforward, very simple demonstration of how we can actually use of the different approaches that we can take using either bindings or dependency injection to work with Cosmos DB within our functions. But yeah. Okay, let me go back to the presentation. Oh. All right. Cool. So if you want to learn more, I've got a couple of resources up here, and I will share the slides probably through GitHub, and I'll also share the demo code so you guys can just have a look and deep dive a little bit further into it just to see how all the components work together. But Microsoft Learn is a fantastic place to actually go and find out and learn a little bit about just Cosmos DB and Azure Functions by themselves in general. And there is a course there that combines the two together, which is really good if you want to get some hands-on practice with it. Definitely check out the documentation as well for both Functions and Cosmos DB. There's a variety of different use cases and different ways that you can use functions, which is really, really cool. And then if you want to deep dive into Cosmos DB, the engineering team have created 2 days worth of deep dive labs that go deep into the specific concepts such as consistency, partitioning, indexing, and they're really, really valuable if you've never used Cosmos DB before. But if you're coming from a relational database background, it's a little bit of a different beast compared to it is a bit of a different beast. So it's really worthwhile, I think, actually going through and going through that content and just getting your heads around Cosmos DB a little bit further. Gotcosmos.com is a fantastic website that the Cosmos DB team have actually created just for more of architectural patterns and just for a high level overview if you're just getting started with Cosmos DB. And then around, I think, Christmas last year, around December last year, sorry, the Azure Functions team did this 25 days of serverless challenge. So for each day before Christmas, there'll be a different challenge using Azure Functions, and you get to play with a variety of different triggers and input bindings and stuff like that, not just Cosmos DB. So if you're looking for a more hands-on approach, a more practical approach to learning Azure Functions, that's a really cool way of getting your heads around that. Cool. Well, thanks for listening. I'm on Twitter. There's my Twitter handle. I'll put the slides up and the demo project up on GitHub when I can. Feel free to connect with me on LinkedIn if you have any questions that I'm unable to. That if you think of a question later, just feel free to reach out to me on either LinkedIn or Twitter, and I'll be more than happy to answer it for you. Cool. So thanks for listening. I'm really grateful for you guys for giving me this opportunity to talk to you all today, and really grateful for being given a chance to speak. So if we have any questions, feel free to ask. Hello? Okay.
Hello?
I'm looking at the chat. Doesn't look like there's... Hello?
Hello, can you hear me?
Yeah, I can hear you.
With your experience, just a quick question. This might look a little bit off, but it's kind of related as well. Between using MongoDB and Azure Cosmos with Azure Functions, which one do you think is much more better? In what category would that be?
Sorry, you were cut off just towards, so more easier or more?
Which one is better, and depending on what category would that be in terms of the usefulness and the area to which you are using it as well?
So I've used a little bit of Mongo, not enough to compare them both with Azure Functions or using them with Azure Functions. So I won't be able to answer it like that. I do know I've played a little bit with it. It's not wildly difficult to set up. So I created like this proof of concept, working with a MongoDB Atlas data service, and it was fairly straightforward to set up. The MongoDB API and Cosmos DB is, in terms of parity with working with Azure functions, it's pretty much like for like. I think there are some discrepancies between the two. My general advice, and I hope this is helpful, is if you're looking to be a bit more hands-off with your database, so you're not too worried about configuring it, or you don't really want to spend your time managing it or sharding it or doing that, I would go with Cosmos DB, just as a personal preference, and having not experienced MongoDB too much. Yeah.
Okay, all right. Thank you for your input.
Just another question for myself. So you did show the different sort of interaction there. So particularly just interaction with the Cosmos DB and the Azure functions. Are there any scenarios, say for example, that you would outside of using the Azure functions, well, not outside of using the Azure function, but probably including using the Azure functions to kind of interrogate the Cosmos DB, perhaps using, I'm guessing obviously the Azure function is using an API. Is that fair to say? You're exposing it as like an external service of some sort?
So just to get some more detail out of your question, so maybe using, say, instead of Azure Functions, ASP.NET Web API, or maybe using it with Node.js. Is that what you're asking?
Yeah, something like that. Yeah.
Yeah. Yeah, you absolutely. There's not just the .NET SDK that you can use Cosmos DB for. So there's a JavaScript API, Python API. One of the examples that I used essentially was integrating it with Databricks. So traditionally in the past, Cosmos DB was what we really refer to as a transactional database. So you wouldn't perform any really complex analytical workloads onto it. So you could actually, there's a Spark connector that works with Cosmos DB, again, which is essentially just the change feed, where you can actually just listen to documents and then perform some analytical workloads that way. But in Build 2020, they announced Azure Synapse Link for Cosmos DB, and essentially what you can do is you can enable what's called an analytical store on your containers. And what it does is you still have your transactional store, but then what happens is your data gets replicated to an analytical store within 5 seconds of it being persisted to the transactional store. And then from that analytical store, you can actually perform queries in Azure Synapse Analytics to perform those more complex analytical workloads that you may be required to do. And this is great because it doesn't have any impact on transactional workloads. So with transactional workloads, when you provision throughput, one of the pain points as a developer when coming to Cosmos DB is actually the cost, or used to be the cost of it, because people didn't really understand, myself included, how throughput works and how you're charged for throughput. So the great thing about Synapse Link is you can perform analytical workloads on your Cosmos DB containers and it doesn't have any effect on your transactional workload. So you can still provision throughput for it, but you don't have to provision extra throughput to perform analytical workloads on your data in Cosmos DB. So that's kind of the non-Azure function way of working with Cosmos DB. And the SDK is pretty flexible, so you can run .NET Core applications onto it as well. So yeah, you aren't limited to just using functions with it. There's within the .NET ecosystem, there's several ways of working with Cosmos DB, and then also outside of it, there's a Python SDK, JavaScript SDK. I want to say there's a Go SDK as well. I may be wrong on that though. yeah, there's variety. This is just one way that you can actually work with data in Cosmos DB. There's quite a few ways of working with it. I hope that answers your question.
Yeah, thank you.
Awesome. Got a question in the chat. What are petitions in Cosmos DB and how can we make our query execute faster? Okay, so there's quite a lot to petitioning, but I'll just try and explain it at a really high level and just looking at time. Oh, I've got a bit of time. Okay, so the way that we achieve scalability within our containers in Cosmos DB is through petitioning. So what we've got here, I will share my Cosmos DB portal with you just to illustrate this a little bit better. Okay. So with petitioning in Cosmos DB, there are two ideas that you've got to keep in your head. So there's logical petitions and physical petitions. Now, logical petitions are essentially the path that we petition our data from. So if I look at my aggregate table here, this city name property is a property path within my document. And in this container here, if I just go into scale and settings, we can see that it is petitioned by this property name of city name. Now, essentially what happens is every time we add a document to this container, we will create a new logical petition for every different city name value. So if I go back into my items here, we've got a city name of Sydney here, we've got a city name of Auckland here, and Redmond, etc., etc. And these are logical petitions. These logical petitions are then mapped to what's known as physical petitions in Cosmos DB. Now, these are just the physical machines in the background. You don't manage these. You don't worry about mapping your logical petitions to your physical petitions. These are just machines at the back that essentially store your data on. And with these physical petitions, you could have many different logical petitions onto your physical petitions. And essentially, there are limitations on your physical petitions. So you've got it can go up to 10,000 request units, or I think it's 10,000 request units and 20 gigabytes of data. So once you if you provision more throughput onto your container, you create more physical petitions. So say if you have 20,000 request units provisioned on a particular container, you'll have 2 separate physical petitions. Or if you have data that's been, you've got 20 gigs of data on one physical petition, another physical petition will be created. So the idea is with petitioning, depending on the workload requirements of a container, you would create a petition that's optimized for it. So in this example, we've kind of created this container to optimize any queries that are looking for city name. So essentially, when we query for hotels, as we were querying for hotels from Redmond, we would be querying the data within that logical petition. That's kind of like a real quick explanation of what petitioning is in Cosmos DB. And there's a second part to your questions. How can we make our queries execute faster? Can we create indexes in SQL, or can we do something similar? Okay, so what you can do to make your queries execute a little bit faster, there's a whole science behind data modeling in Cosmos DB that's in NoSQL databases that's a little bit different to relational databases. But essentially for indexing, Cosmos DB indexes all your data automatically, but here we've got an indexing policy defined, and essentially with that automatic indexing on every policy, we just in our included paths here, we're just telling this container to index every single path that's in our JSON document. And what we can do, depending on the, again, it comes back to what type of workloads you're going to be performing on a particular container. So if you're doing read, if you're trying to optimize for reads, you could potentially just index the paths that you're going to be performing queries on. So for this aggregate example, instead of indexing everything, I could just index the city name property. And then depending on what kind of values that are falling underneath that property, we could just put a string property, we can add a wildcard, etc. Or if we're dealing with arrays, we can index the this was a parent object for our arrays underneath it, we can just index the properties underneath that. And that way we can just make our queries execute just a little bit quicker because they'll consume less request units. And depending on the amount of request units we provisioned, if we reduce the amount of request units that each query is consuming, we can execute more of those per second. So that's how we can just make our queries execute a little bit faster. Again, I hope that answers your question. Awesome. Any more questions? Okay, well, I think I'm handing it off to someone else. Let me find out who's next.
Okay, where is me?
Oh.
Okay, Innocent.
Hey.
Yeah, okay. Let me change my slide. Okay.
All right, thank you all. It was a great session. So let me stop the recording. As said, sessions are being recorded, will be published on the YouTube channel. So follow the Power Community 365 Saturday on the several channels, and you will see the links being published. So we have a couple of minutes for introducing the new speaker. So what I'm gonna do now is show the agenda one more time here. We have Eng Song Chi, hope I pronounced them correctly, going back into security and talking to us about Azure Sentinel with Office 365. So we have a couple of minutes, so I suggest everybody take a quick break, and we're gonna be back soon for the next session about Azure Sentinel. Thank you.